Hello, I am Dr. Ajay Sharma, Department of Electronics and Communication Engineering, James Engineering Management Technical Campus, Greater Noida. The subject that I teach in this semester for BTech 5th semester student is digital communication, and the topic that I discuss today is binomial distribution and Poisson distribution. Actually, binomial distribution is a discrete probability distribution. Means the binomial distribution comes in the category of discrete probability distribution. Means that has a possible limited outcomes. So binomial distribution is a discrete probability distribution that is used for data which can only takes one out of two values. Means you have two choices, and out of two, one is your favorable. Means one you want from two, and this is your success. For example, if you toss a coin, you have only two options to come, either tail or head. No third value possible. Only two values possible. One is head, other is tail. So if you want head, then head is your favorable, right? So your success is head. So if you toss a coin 10 times, and if you got a success of 6 times, means 6 times you got head rather than tail. So binomial distribution is a discrete probability distribution that is used for data which can only takes one of two values, that is pass or fail. It may be yes or no. It may be good or defective. So you have only two choices. So binomial distribution allows to compute the probability of the number of successes for a given number of trials. Right? So number of times you toss a coin, for example, 10 times you toss a coin means 10 number of trials that you have, right? And each is either a success or a failure. If you get head, you get a success. If you get a tail, you are not success. You are failure. So each is either a success or a failure, given the probability of success on each trial, right? So success could mean anything you want to consider as a positive or a negative outcome. So success may be your negative outcome or positive outcome. It only depends upon you what you want out of two possible outcomes, right? So binomial distribution, there are some important points regarding binomial distribution that I will discuss one by one. Assume that you are tossing a coin 10 times, right? You will get a number of heads between 0 and 10. Means if you toss a coin 10 times, then you have a number of heads, maybe 0, maybe 10, maybe 5, maybe 6. So any value between 0 and 10. Then you may then carry out another 10 trials in which you will also have a number of heads between 0 and 10. Now you perform again this same event after some time, and again you toss a coin 10 times. So again you have some sample points, right? So by doing this many times, when you have a sample points, you will have a data set, you will have a data of each event, and all that event become a data set which has the shape of the binomial distribution. That's why we call it as a binomial distribution. Actually it is the distribution of probability, right? So getting a head would be success or it may be hit. A number of tosses would be the trials, and the probability of success is of course 50%. Each time you toss a coin, you have a 50% chance to get head. So these are very important points regarding binomial distribution. Now, binomial test requires that each trial is independent from any other trial. In binomial distribution, when you perform a certain event, when you toss a coin several times, in this each trial is independent to other. Means if you toss a coin, at a certain time, and again you toss a coin after certain time interval, then these all trials should be independent, right? In other words, the probability of the second trial is not affected by the first trial. This is the meaning. So trial should be independent to each other. Means the result of present is not affected from past, or the future trial is not affected from the present trial. So in short, we can say that in binomial distribution, every trial is independent to each other. So the binomial distribution is appropriate when the following condition applies. Number one, there are only two possible outcomes to each trial, success and failure. Second, the number of trial is fixed. That's why this binomial distribution is come into the category of discrete distribution. The probability of success is identical for all trials. This is also true. The trials are independent. That is, carrying out one trial has no effect on any other trial. So these 4 points are very important as far as binomial distribution is concerned, right? Now, mathematically, how you calculate the probability of success? This is the final mathematical expression for that. So the probability of R success, R is the success out of N. So PR is given the following binomial formula. So this is the binomial formula in binomial distribution. PR is the probability of your success. So in this formula, PR is equals to factorial N upon factorial R, factorial N minus R into P to the power R, and then 1 minus P to the power N minus R, right? So where P is the probability of success, then probability of failure is 1 minus P, that you already know, and number of independent trials. So total number of trials performed is N, small n, and small r is the number of success in the N trials, right? So total number of trials is N, and R is the number of success that you get out of N trials, and P is the probability of success, and of course 1 minus P is the probability of failure according to probability. So this binomial distribution is fully defined if you know both N and P. So if you know the value of N and P, you can get the probability. You can calculate the probability in binomial distribution. Then come to Poisson distribution. Actually, Poisson distribution is the extended version of this binomial distribution. It is also a discrete distribution. It is also come in the category of discrete distribution, and it is also sometimes used because if you have a trial, say 1000, right? So 1000 trials when you have, then how you calculate the factorial n? It is very difficult to calculate the factorial n. Fact when n is very, very large. How you calculate the factorial 1000? It is possible. 1000 into 999 into 998 into 997 so on up to into 1. So it is very difficult. Then Poisson distribution come in the picture. So what about, so there are certain very important points regarding the Poisson distribution. First, it is not always appropriate or to classify the outcome of a test simply as pass or fail. Number 1 point. Number 2 point, sometimes we have to count the number of defects where there may be several defects in a single item. Third, the Poisson distribution is a discrete probability distribution that specifies the probability of a certain number of occurrence over a specified interval. Right? So these are the 3 important points regarding Poisson distribution. Again, I say it is a version of binomial distribution. Then with the Poisson distribution, you may examine a unit of product or collect data over a specified interval of time. This point, then you will have a number of success, 0 or more. You may then repeat the exercise in which you will have a number of successes. By doing this many times, you will have a data set which has the shape of Poisson distribution. So these 4 points are also important as far as the Poisson distribution is concerned. Again, there are certain examples of Poisson distribution. Number 1, counting the number of defects found in a single product. Second, maybe the example, counting the number of accidents per year in a factory. Third, counting the number of failure per month for a specific equipment. Fourth, counting the number of incoming calls per day to an emergency call center. And fifth, counting the number of customers who will walk into a store during the holidays. So these are few examples of this Poisson distribution. These are the following experiments that you perform under Poisson distribution and calculate the Poisson distribution probability. So the Poisson distribution is appropriate when the following conditions apply. Now I will discuss this condition one by one. Number 1, occurrence takes place within a definite interval or area of opportunity. Means per sample, per unit, per hour, etc. Number 2, occurrence takes place at a constant rate, where the rate is proportional to the length or size of the interval. The likelihood of occurrence is not affected by which part of the interval is selected. Example, the time of a day. Fourth one, occurrence takes place randomly, singly, and independently of each other. Now for Poisson distribution, how you calculate the Poisson distribution probability? This is the mathematical formula. This is that we call as a Poisson formula. The probability of R occurrence is given by, of course, out of n, by the Poisson formula. PR, this is the probability of R occurrence, R success, is equals to lambda to the power R e to the power minus lambda upon factorial R. And you can see that in that particular formula, there is no n. There is no total number of possible outcomes n. That had been seen in a binomial distribution case. And that creates a problem for us, because if the value of n is very, very large, then factorial of n, calculation of factorial n is very much difficult. So in this particular formula, there is no n. So in this formula, if you know lambda and R, what is lambda? Average or expected number of occurrence in a specific interval. And what is R? Number of occurrences. Then you can easily calculate the probability of R, probability of your success or occurrence in Poisson distribution by knowing the two factors, lambda and R. Lambda is average or expected number of occurrence in a specific interval, and R is the number of occurrences. So the Poisson distribution is fully defined if we know the value of lambda and R. And that's all. So this binomial distribution and Poisson distribution, these are the two distributions that come in the category of discrete. This discrete distribution, as far as your syllabus is concerned, these are only two discrete distributions, and these are important. Questions may be asked many times in examination. So prepare these two topics, binomial distribution and Poisson distribution. So thank you very much.